Hey everyone, today we're gonna discuss about an interesting topic which is recursion. Actually, it is not meant to be a topic. It is just said to. It is considered as a topic because of its hype. It is a method of simply of solving any problems, but it is hyped as a most difficult method to be solving any problem. But it is not. By the end of the video, you will see it is a simple method. People called recursion the hardest concept of programming. But what if I tell you it is simply a function which is doing its small job again and again until it is set to be stop? This is what simply recursion means. Let's start the video with a concept with a simple definition of a recursion, that a function calling itself again and again to solve any subset of a bigger problem. It is a technique. Basically, it is a technique. Simply, as simple as that. Nothing much bigger than this. The concept of the concept of recursion, you can understand it with a real life example, which is an easy example. Suppose you have created a project, any project other than programming. You have created any one of the project, and you go to your teacher and show him your project. He tells you the flows of the project and say you to upgrade on this. He gives you feedback and say you to make updates. You make updates within a week, go back to the teacher, and the teacher again told you some 1-2 more flaws which were missing. Then again you come home, work on the project, then again you go for submission. So before submitting the project, you done basically, you went to teacher again and again, and the teacher said to you the problems again and again, and then you worked on it again and again. So this again and again calling of functions doing anything is said to be a recursion in coding. There were two functions which were working again and again, the teacher giving you feedback and you working on your project. So this was a simple example of recursion. I hope you got it. Now here a few more things we have to be discussed. A function calling itself again and again is said to be a recursive function. How does a recursion works? A recursive method creates a copy of itself and then work on smaller processes to solve a big problem. It is important to ensure that a recursion terminates where you have to close your function or return a function. Otherwise, what you will face is the function calling itself till infinite times. So it is important to terminate a function, otherwise it will call itself again and again. Okay. Recursion is a very simple technique borrowed from mathematics. A recursive code, if you try to solve a problem with a recursive code, then the recursive code will be shorter than an iterative code. Now if you are wondering what is a iterative code, simply if you run a loop or you have created an array, iteration is something you traverse through any elements or anything in programming. Suppose you have created an array of 100th element. Okay, now if you have to check, you will perform a function of n times moving from 0th index to 100th one. So this going one by one or checking from each index is said to be traversing. When you have traversed a whole array, you have completed one iteration. So this is a iteration, and the code for this you will usually use a loop. But the code of writing something, the code of solving any problem in recursive method will be shorter than in iterative method. Mostly we use recursion for solving sorting, searching and traversing problems. Recursion is also used in trees and graphs. Okay, now what will be the format of recursive function? You will simply use if-else conditions. Conditions are used to write a recursive function. Okay, you will simply write if, then you will write a base case here, base case. Now then you will simply add some like out system.out of print. You will print any thing related to base case, right? Then in the else condition you will have something, you will return some value in the else, return some else value, which will be the recursive call. Wait. Value which will be the recursive call. Now what is the base case and what is the recursive case? We should discuss it now. What we remember one thing, what we have discussed about, what we have learned about recursion is recursive function is something which will call itself again and again. But sometimes in a code, while writing in a code, you will face something where a statement will not call itself again and again. This where a function will not recurse. This is said to be a base case. Quite confusing, right? For now, just remember one thing, that base case is a condition where you will say the function you have to stop. Base case, simply base case is a condition where the function needs to stop. Okay, and a recursive case is a condition where the function will call itself again and again. Okay, for now just remember one thing, that a base case will be a condition where the function has to be stopped, and the recursive case is a condition where the function will call itself again and again. We will see its example, through what you will get a clear understanding of it. Till now these are your notes for doing something. For recursion, you can just take simply a screenshot of this, or you can type this. What else? One of the basic example of recursion, which is said to be of finding factorial finding. This is one of the key example which is while studying recursion, this is kept in mind. So now if you don't know what is a factorial is meant to be something that a whole number is multiplied by its downward movement till it reaches to 1. For suppose you have to find the factorial of 5, you will factorial of 5, you will just simply write like this, give an exclamation mark. This exclamation mark is said to be of factorial. Now you will write equals to, it will be equals to 4 into 3 into 2 into 1. Okay, sorry, 5 also. 5 into 4 into 3 into 1, which will be is equals to, wait a while, 5 for the 20, 23 the 320 the 60, 260 the 120, and 120 into 1 equals to 120. So the factorial of 5 will be 120. This is how a factorial is calculated in mathematics. But here is the thing, in coding the factorial is termed as, is assumed by a formula, which is factorial of n factorial is equals to n into n minus 1. This is the correct formula, correct way of finding any factorial. According to this, the factorial of 0 will be 1, right? Okay, according to this formula, n factorial equals to n into n minus 1. If you need to find the factorial of 5, if you need to find the factorial of 5, it will be equals to 5 into 5 into 4's factorial. I forgot to add here. So if you need to find the factorial of 5, you need the factorial of 4. If you need to find the factorial of 4, you have to know the factorial of 3, and like this you will need to know the factorial of 2. Like this you will need to know the factorial of 1. So is this somehow related to recursion, right? This is what the recursion is done. For finding a factorial of one thing, you will need to find the factorial of other thing. For other, you will need to find the factorial of other thing. This is also said to be recursive function, recursive calls. Now if you are wondering, still wondering how the factorial of 0 is equals to 1, this is a very interesting mathematics. Basically what factorial means is the ways to write something, or the ways to arrange something. If you have 5 items, the ways to arrange 5 items are 120. There are 120 ways to arrange 5 items. I can write it down here. Factorial is a way of arranging something. Still the spelling is wrong. You have 120 ways of arranging 5 items, right? So now according to this concept, you will have for arranging nothing or 0 items, you will have only one way, which is nothing. Actually, this is a very fun kind of concept. For arranging 0 items, you will have only one way, which is to do nothing. So this is how factorial is calculated. Of 0 is equals to 0's factorial is equals to 1. That was a simple mathematics. Now if you want a code example of factorial, is how, first moving towards factorial, let us understand the code example of how a recursion works. First we will create a class, public class recursion. Now a main method, now it is good to type. Here we create a function other than a main method, outside of a main method. So static void, we can type it as a message. We can name our function as message and print here hello world. And now call it in the main method. So if you try to run this code, you will get an output of hello world, right? Now I have to print this hello world 5 times. What I can do is simply just copy this out and print it 5 times. Okay, and now run it. My message, the hello world, will be printed 5 times. What else I can do is, rather than doing this, what else I can do is, I can copy this whole method and paste it 5 times, 1 2 3 4 5, and just rename the methods like message 1, message 2, message 3, message 4, and then in the main method I can call message 1, then message 2, then message 3, then message 4. Okay, now if I simply just try to run this, I will get printed hello world 5 times. But is this the shortest way of doing this? No, this is not. I don't want to call these functions again and again. Now how I can print this all functions by just writing message 1 time and I get the output of hello world 5 times. How can I do this? I can simply add a recursive call in message. In message I can call the second function, which is message 1. Then in message 1 I can call message 2. Getting this? In message 2 I can call, I can call message 3, right? Now in message 3 I can call message 4, message 4. Now in message 4 will call nothing. So here what is happening, one function is calling another function to give us the output. See, we got the same output and the code redundancy has been decreased. For achieving a good redundancy, we use recursive calls, right? Now if we see, if we delete this all, and consider our factorial problem, then here we can create like, firstly we have to create a function out of the main method, static int, okay, factorial, we can name our function as factorial, and then in factorial what we can do is run a condition if n is equals to 0, then return 1. What simply we have given, we have, this is set to be a base case where the program has to terminate. If the n is equals to 0, then the program will terminate, the function will stop calling it again and again. So here is the if condition. After if, we can give else, or what if we don't write else, we can just simply write n, return n into n minus 1. Okay, sorry, factorial, here we have to call as factorial. Now in the main method we have to call this function of factorial. Wait, firstly we will create a variable of naming result data type int result equals to factorial int n. Here the n is initialized, and now factorial will store result. Here you have to give any value of n, which we can say 5. Okay, or you can simply don't write anything here. Yeah, there we haven't write static factorial int n. Okay, now I guess it is correct. If we run this, we will get the answer of the 5 factorial, which is 120. Okay, so this was a simple recursive concept. I hope the recursion is now clear. You will get these notes and this code example. So for now, this was the video of recursion, but the recursion doesn't end here. Till now you are good to go on recursion. You just have to remember these concepts. Before starting dynamic programming, we will have another video of recursion where we will discuss its problem, which are important to be addressed. Till now, this is the video of recursion. This is the whole concept. I hope it is cleared of you guys.